All right, hello again, Algebra 2 people. So today we are going to be starting what is arguably like the single most important topic in all of Algebra 2. Um, Not saying the other things we covered aren't important, you won't see them again, but this one that we're starting today with factoring it's like it'll never go away. You'll see it in geometry, you'll see it in pre-calculus, you'll see it in calculus, you'll see it in college algebra. Any other math course you take, you will see factoring. Okay, and so the one thing to keep in mind on all of these things, we're going to be working with standard form. So remember that's ax squared plus bx plus c. And generally speaking, they're all going to be equal to 0. I'll talk more about that in just 1 second. Um, what we're going to be doing today is just talking about when a is equal to 1. It's kind of what, the quote unquote easier case. In the next video, we'll talk about how to do things when a is not equal to 1. And we'll see a couple of examples at the end of this where a is not 1, but it's just a GCF. So it's really the same technique. But then tomorrow we'll see some different techniques. Okay? So really what we wanted to be able to do is two things. We want to be able to factor it and write what's called factored form, which you see right here. This format right here is going to be factored form. So when you see, if that's all it asks for is the factored form of the quadratic, we're just going to say, writing it in terms of the parentheses. But then we're also going to find the solutions. Okay, remember, other word for solutions, x-intercepts, roots, or zeros. So we're going to do that kind of at the same time because it's just one extra step. Okay, so we're going to jump in here and see what happens. So what's important is what's written in red. What multiplies to C and adds to B. So remember, your C is always going to be your constant, and your B is going to be the coefficient of the x term. So how can we multiply to get positive 12 and add to be positive 8? I will say this, and the more comfortable you are with your times tables, the faster you're going to be at this, because you can kind of start doing it in your head. If you can't do it in your head quite yet, then you can always just write out what the different pairs are. We're looking for a pair of numbers. So we can multiply to 12 to get 1 times 12. We can do 2 times 6, or we can do 3 times 4. And since C is positive and B is positive, then that means all the factors have to be positive. So which of those pairs could I also add together to be 8? And in this case, the answer would be 2 and 6. So my factored form would be x plus 2 times x plus 6. And I'll solve that equals 0. So that is your factored form. Done. Also, it's important to say this too, the order doesn't matter. So if you wrote that as x plus 6 times x plus 2, totally cool, that's fine. Okay. Now for the solutions, what we're going to do for the solutions is we're going to take each of these factors, set it equal to 0, and then solve. So we have x plus 2 equals 0. That means x equal to negative 2. And if we have x plus 6 equals 0, then that means we have the other solution is x equals negative 6. Okay, that's it. We have solved, factored and solved that quadratic. Remember what the solutions tell you. The solutions tell you where it's crossing the x-axis. So if you're to graph this either by hand or on a calculator, that parabola is going to cross where x equals negative 2, and then again where x equals negative 6. Okay, that's the whole process, folks. And I've got a bunch of examples that I'll let you pause the video and do a couple of them on your own. But that's really the whole process of factoring and solving. How do you multiply to the C value and then combine those numbers adding wise to get to the B value? So let's go and do example 2. So there's my C, there's my B. So think to yourself, what can I multiply? How would I multiply two numbers to get 18, but the same two numbers had to be positive 9? Well, in this case, it would be 6 and 3. So my factored form would be x plus 6 and x plus 3 equals 0, because again, 6 times 3 is 18, 6 plus 3 is 9. And remember, you can always check this too. If you do FOIL or the box method, you can multiply those guys together and go back and double check that you get the same answer that you started with. Okay? Once you have it factored, define the solutions. Set the first one equal to 0, solve it. Set the second one equal to 0, and solve it. And that's it. Okay? It's really important. A couple of things I'm going to say right now before I do the next example. It's important that you know the vocabulary. So if a question is asking for the factors, you're looking for these parentheses expressions. So like one factor is x plus 6. Another factor is x plus 3, and we can multiply those together to get the original question. If it's asking for these solutions, you got to factor it first, but then you set each factor equal to 0 and solve. And then those numbers are your solutions. The next thing I'm going to say is, you might be saying to yourself, well, can I just change the sign? Once I find my factors, can I just change the sign to get the solutions? On today's question, the answer is going to be yes, but on tomorrow's, it's not really going to be yes anymore. So it's really important that you see why we're changing the signs, because we're setting each factor equals 0 and then solving. Okay? So if you want to go and pause the video real fast and see if you can do example 3 on your own. So again, what multiplies to 20 and adds this time to be negative 12? So how do you multiply to be positive 20 but adds to be negative 12? Well, in this case, notice if I'm multiplying to a positive but adding numbers to be negative, that's telling you both factors would have to be negative. So you can do negative 1 and negative 20, negative 2, negative 10, negative 4, or negative 5. Those would be my options to get positive 20. And then which of those can I add together to get negative 12 in the middle for the v value? And it's going to be that. So my factored form, those are my factors. And then for my solutions, again, you set them each equal to 0 and you solve. Okay? And that's the whole process, folks. So we're going to jump through these next couple of examples a little quicker, but before I do that, I want to make sure you notice one thing. Take a look at example 4. And just look at it real quick, and if you need to pause the video, how is example 4, how does it look different from the first 3 examples that we just did? And I think you probably said to yourself, well, it's not equal to 0, right? So all these things, they have to be equal to 0 before we do anything else. So all I'm going to do is I'm going to move that 30. So I'm going to subtract 30 from both sides. And write this as x squared plus 7x minus 30 equals 0. And then factor it. You have to, and on any question you see, if it says solve, factor it or solve, just move everything to one side of the equation, set equal to 0, and then factor it and go from there. Okay? So again, how do we multiply to be negative 30, add to be positive 7? Notice in this case, since my c is negative, then I've got 2 different factors. I've got one factor that's going to be positive and one that's going to be negative. I can still write my pairs. 1 30, 2 and 15, 3 and 10, 5 and 6. I know one of them has to be negative for when I multiply to get negative 30. And since my middle number, since my b is positive, then that means my big number has to be positive. So these all have to be positive numbers, and then the small ones would be negative. So again, take a look at your pairs, which one could be combined just by adding to get positive 7. And in this case, it's that third pair, that negative 3 and positive 10. So my factored form would be just like that. And then for the solution, we still do the exact same thing. And remember, what does that mean? That's telling you where the parabola is crossing the x-axis. So I'm going to have you guys pause the video real quick and see if you can do example 5 and 6 on your own. On number 5, you do have to move that x over. So you're going to start off. We'll go and start this one. So if we subtract x from both sides, we'll have that. So see if you can write your factored form. And then find your solutions. And then number 6 is all set up, ready to go for you too. So I'll give you a couple seconds to pause the video, work on those, and then I'll kind of zip through these solutions for you. Okay, for example 5, what multiplies negative 12 adds to be negative 1. Remember, there's a 1 in front of there. If you don't see the number, it's always going to be 1. So that means it's going to be x minus 4 and x plus 3. For your factors. And then for your solutions, it'll be x equals positive 4 and x equals negative 3. Same thing on example 6. What multiplies to negative 60 adds to be 4, positive 4. That's going to be x plus 10 and x minus 6. 10 times negative 6, negative 60. 10 minus 6, positive 4. And then for your solutions, excuse me, you have x equals negative 10 and x equals 6. Okay. So the last couple examples I'm going to do are going to have an a value. But these are going to be kind of special a values. Sometimes you might see something that's important that we recognize this when this happens. If you have an a value, the first thing to look at, can you just take it out? Can you factor it out as a GCF? Greatest common factor, right? So in this case, if I notice I got 3, 18, and 24, if I divide all of those by 3, in other words, that 3 is my GCF, then I can rewrite this thing as 3 parentheses x squared plus 6x plus 8. It's kind of like doing the reverse of the distributive property, right? Now when I factor it, all I care about is this inside right here. That 3 is going to hang out, but I still ask the same question. How do I multiply to be 8? And how do I add those same pair of numbers to get 6? So in this case, your factored form would be 4 times 2 is 8, 4 plus 2 is 6. So we have that. And then when you solve it, you don't need to worry about the 3 that's outside, because if you set 3 equals 0, that doesn't make any sense anyway. So all we need to worry about are the factors with the x involved. So for the solutions, x plus 4 equals 0. So x equals negative 4. And x plus 2 equals 0. So x equals -2. The last example works the same way. Again, like I said a second ago, what's my GCF in this case? Can I take it out of that front number? Well, that front number is 1, so my GCF is really just -1. So if I divide everything by -1, how does that make a new equation? Well, now it's going to be -1 times x squared minus 4x minus 21. And again, all you got to worry about is in here. By the way, if you just wrote a negative in front instead of -1, that's fine too. So how do you multiply to be -21? And that same pair of numbers add to be -4. Well, the only pair that you can get to -21 would be 1 and 21 or 7 and 3. But and if you have a -7 and a +3, multiplies -21, adds to be -4. So that's your factor form. And for your solutions, we have x minus 7 equals 0. So x equals 7. And x plus 3 equals 0. X equals -3. Okay. So I've got 5 examples here. If you want to pause the video and see if you can work through all 5 of those. And number 1 is actually it's basically the same as example 1 on the left-hand side over there. But if you want to work through number 2, 3, 4, and 5, and pause the video, and then I'll kind of run through all of those factors and solutions, and we'll wrap everything up. Okay, so again, I'm not going to do number 1 because it's basically the same as that example right there, so it's the exact same thing. For number 2, it's all set up, it's equal to 0, there's no GCF. So what multiplies 24 adds to 14? That's going to be 12 and 2. So that's your factored form. For your solutions, would be x equals -12 and x equals -2. For number 3, I do have a GCF. I can take a -1 out. So take a -1 out, it becomes positive 3x minus 10. And if you factor the inside of that, so we'll multiply as -10, add to be positive 3, x plus 5 and x minus 2. And then for the solutions, x equals -5 and x equals positive 2. Number 4, we got to do 2 things. So we have to move the 80. So we got -80 equals 0. And then we have GCF. So we have take 4 out of everything, divide it all out. And of course, you wrote that as -1x for your b value. That's totally good too. So now we can factor the inside. Remember, the 4 kind of comes along for the ride. So what multiplies -20 adds to be -4. You factored your -5 and +4. So your solutions are 5 and -4. And the last one, again, we got to move the 8x, so subtract 8x from both sides. And then multiply to 15, add to be -8. So that's going to be -5 and -3. And your solutions will be +5 and +3. So that is factoring when you have A equal to 1, even if you have a GCF you have to worry about. Make sure everything is always set equal to 0. And you're looking for the factors that can multiply to C and add up to B. We're going to use the same process tomorrow when A is not 1 and it's not a GCF. So we'll continue the whole factoring and solving thing in the next video. If you have questions, please let me know. Come into tutoring, talk to your teacher. Until next time, stay safe.